right, so let's look at this one. So what kind of power do I have here, even or odd? Even. So as soon as you see there's an even power, you know that you're going to use this identity. That sine, and I only have sine here, right? Sine squared of theta is what? Half. Yes, very good. A half 1 minus cosine of 2 theta. I don't have any cosines yet, so that's the one that I'm going to use. So this is the integral of 1/2. Well, let me do one more step before I write that. Let me write this as, because some of you had problems with this. This is sine squared x to what power?
3.
Then what? dx. Why is it 3? Because 2 times 3 gives me what? 6. Right? So remember, our power rules are this. So you've got a to the power n to the power m means a to the power n what? M. Right? So if I've got like a squared, then cubed, what does this mean? This means write a squared how many times? 3 times, right? So this is a squared, right? And what does a squared mean? It means write a how many times? 2 times. So this is like a times a times a times a. So how many a's do I have now? 6. So that's a to the 6. Right. This is just algebra. A lot of you had problems with this on the homework. That's why I'm doing it. And the other one is a to the n times a to the m is a to the n plus m. Why is that? Because like if I've got a squared times a cubed, this means a times a, right? This is a squared. And this means a times a times a. That's a cubed. How many a's do I have now? 5. So what do we do to the 2 and the 3? Add it. Okay? I don't want anybody to make this mistake again. Here you count 2. Right? Yes? All right. I'm not ever going to go over this again. So, all right. And we're going to erase it so there's no proof that we even did this. There. Proof. Gone. All right. Let's do this. So integral. Now, instead of sine squared x, I'm going to write 1/2 1 minus cosine of 2 theta all to the power 3 x. X, 2x, dx. All right. Now, let's raise it to the power 3. So I get 1/2 cubed means 1/2 times 1/2 times 1/2 is 1 over what? 8, right? Then 1 minus cosine of 2x all to the power 3 dx. So this is where we use Pascal's triangle. Did I go over this with you in class yesterday? No? Pascal's triangle? No. Okay. Well,
We just 1 minus cosine times 1 minus cosine.
Times 1 minus cosine. Okay, I'm going to go over that. Aaron? 1 over 2 times 1 over 2 times 1 over 2. See this cubed over here? It means 1/2 cubed times 1 minus cosine of 2x. And the 1/2 cubed is 1 over 8. Right here. Okay? All right, so let's do this one. So, one minus cosine of, I'm going to do the Pascal's triangle on the corner here. So this triangle just gives us the coefficients when we're taking a plus b to the power n. Okay, so you've got 2 things being added raised to the power n. You put a 1 at the top, then you put a 1 in this corner, 1 in this corner. All the way down, we're going to have 1s. Right. You remember this now? So you put a 1 here, you say 1 plus 1 is 2, then you put a 1 here. Then you put a 1 here, you say 1 plus 2 is 3, 2 plus 1 is 3, and then you put a what here? 1. What do you think the next row is going to be? 1, then what? 4, 6, 4, and then what? 1. So this gives the coefficients of a plus b together. All right, let me show you how. So we're completely going on the side here. So if I want a plus b squared, what I do is I start with a squared, then ab, then b squared. All right, so the first one to the power 2, then subtract 1 from the power of a, add 1 to the power of b, so you get ab. Subtract from 1 from the power of a, you no longer have any a's, right? Add 1 to b, so you get b to the power of what? 2. Okay? These give the coefficients. So I look at this row. It says the coefficient of the first one is 1, this one is 2, and the last one is 1. So that's what a plus b to the power 2 is. It's a shortcut. Okay? When I gave you that extra credit yesterday, a lot of you got messed up because you weren't multiplying these correctly. Let's do another one. So if I want a plus b to the power 3, I look at the row that starts with 1, 3. This row here. Okay? And I start writing it like this. A cubed, what's the next one going to be?
3 plus 3ab.
A, subtract 1 from A. It was 3 before. Now it's going to be what? 2b. Then what's the next one going to be? 3a b squared. What's the next one going to be? B to the power what? 3. See, these have to always add up to 3. A cubed, a squared, b, ab squared, then b cubed. The powers always add up to 3. That's 3, that's 2 plus 1 is 3, 1 plus 2 is 3, and this is 3. It's a shortcut. Last one, let's do this one too. A plus b to the power 4. All right, what's the first one going to be? Okay, a to the 4th. What's the next one going to be?
3.
Uh-huh. Then what? B. Next one? 6. A squared, b squared. What's the next one going to be?
4.
B to the 3. And what's the last one? B to the 3. So you don't have to sit there and multiply it by itself 4 times. Because if you get to the power like 10 or something, do you want to multiply something by itself 10 times? No.
That's the only way.
What?
That's the only way. I know how to do it.
But now you know a different way to do it, right? So if you want to get to the 10th power, you continue going until you see 1/10. Right? You're going to use this with statistics and probability. Who's already seen this? Diamond, you've seen it. In statistics and probability, right? In high school. Where do you see it? You saw it here. Anybody else see this? Okay, all right, so this is a shortcut. All right, so let's go back to our problem.